Well, this is a series where I take a look at one of Flat Earth Flyer and discuss/debunk one section at a time. So far we covered water is a natural level, airplane level flights, science says is stationary, horizon is always eye level, we see too far, and dome is real. Today, moonlight is cold. A laser thermometer proves moonlight is colder than in the shade. The fact indicates that the moon is not a reflector of the sun's light, but rather a light source in and of itself. Depending which flat earther you're talking to, this can be a two-pronged attack. First, if moon is not reflecting sunlight as we know in a heliocentric model, then it must mean that heliocentric is incorrect and thus geocentric model is correct where Earth is in center. Furthermore, Abrahamic God says moonlight is colder. Also in biblical cosmology, God created a vast solid dome called the firmament on the second day to divide the primal sea into upper and lower portions so that the dry land could appear, and God called this firmament heaven, thus proving by association of a dome and flat earth. I'm glad this will be a much shorter video compared to the other debunks, hopefully. First we'll go through the issues with their experiments, followed by the pitfalls, and finally understand why it happens. But first, can I say what I think is grammatically incorrect, or at least bad English, but it sounds so cool. Flat earthers can't science. Seriously, they don't seem to understand the concept of control variable. On most of these so-called experiments, we find these flat earthers just going outside at night, pointing at something in moonlight, then pointing at something in shade, then jumping to conclusion. Who can see the myriad of problems here? The first thing that came to my mind was heat capacity. It's just because I'm obsessed with water. Heat capacity or thermal capacity is the physical property of matter, defined as the amount of heat to be supplied to a given mass of a material to produce a unit change in its temperature. What does that mean? Well, simply put, given the same heat, different materials would have a different temperature. Glass has a higher heat capacity compared to, say, almost all common metal like iron, lead, copper, and so on. So if you leave a glass item and a metal item outside in the sun, you could touch and feel the difference. It would be a flawed experiment though, unless both the item has a similar dimension. On one experiment by Jerry Rogers, we see him measuring a floor mat and then concrete. Different heat capacity. If you left both of them under the heat, they would have different temperature anyway. So this is flawed. If performing this test, one needs to use the same material. Next, suppose you find a difference. Your hypothesis and not conclusion at this point is, it is the moonlight that is making it colder. How do you confirm it? Well, you repeat the same test with a moonless night and confirm that on a new moon night, those two values are now the same, and thus it was the moonlight that caused the change. Technically, even that can be biased due to other variables. Imagine a summer day. If there is no clouds in the sky, more of the sun's heat reaches the earth and it becomes hotter compared to having cloudy skies where some of the rays are getting blocked. At night, the exact opposite effect takes place. In a clear sky, all the heat emitted from Earth's surface freely escapes into space. But on a cloudy sky, some of this heat is trapped and re-emitted back towards the Earth. Which means, on a full moon, you can get a shade reading which might be different than when you did the reading at new moon. And that would be due to all those external variables like clouds, tilt, and so on. Maybe you should look at the difference and calculate a ratio. And if your moonlight cold theory is correct, it wouldn't matter. as you read the same value in both shade and non-shade at new moon. Let me know how it turns out. Some flat earthers like D-Marble at least uses the same material, an aluminum foil. I can mention several issues with his experiment, but let's not do all. His test was laying out what looked like a bit crumpled aluminum foil. One side is designated to be the Moonlight part. From the video I have seen, it's not apparent if it's the same piece of foil or two separate pieces with gap in between. First he tried to measure both sides, but the values kept fluctuating by 5 to 10 degrees in Fahrenheit. Why do people use bloody Fahrenheit? Coming from someone who says 70 miles per hour is national speed limit. Anyway, that much fluctuation might have deterred us mere mortal, but not D-Marble. He then proceeded to cover the non-moon side with what seems like a wooden block, measured again, and found the moon side to be cooler. Case closed. Okay, explanation with examples. You're seeing two thermometers I use while cooking. One is obviously the laser thermometer all these flat earthers are using. The other I believe is called a mid thermometer. Obviously for the mid thermometer, the metal rod is getting heated, which is then measured. Now imagine a pot of water. As the water is heating up, water nearer the bottom of the pot is hotter than, let's say, the very surface. If I stick the mid thermometer at the surface, that should give me a lower reading than if I stuck it all the way to the bottom of the pan. Makes sense, right? Now when I use my laser thermometer, what is going on? Is it giving me the surface value or is it giving me the bottom of the pan? We mostly assume this is like a laser sight, so it has to be the spot is touching, right? Bottom of the pan. Well, not really. A laser thermometer technically is an infrared thermometer. That laser is there just for aim. If we read the bloody manufacturer's detail, it even tells us infrared thermometer have a lens that focuses infrared radiation onto a detector, which converts it into a readable electronic signal. Because of this, it is possible for nearby objects emitting their own thermal radiation to interfere with the measurement, even the thermal body temperature emitted by the user. So in simple terms, it is collecting infrared radiation emitted around the point to calculate the temperature. Furthermore, most objects have an emitted infrared energy of 0.95, but some objects do have a higher or lower emitted infrared energy. Substances with very low emissive rating, like highly polished metal, tends to be very reflective of ambient infrared energy and less effective at emitting their own electromagnetic waves. So if we pointed at the side of our stainless steel pot filled with boiling water, well, we would be getting a reading closer to the ambient radiation of the room rather than 100 degrees centigrade. Manual for my laser thermometer actually mentions all of this, even with a chart for some common surface emissivity value. But who has time for that, right? So who wants to guess what happened when D-Marble placed the block next to part of the foil? Any takers? Now additional pitfalls for any further experiments these flat earthers wants to perform. 1. Reflected light is not the same as source light. It depends on the surface, distance, and a bunch of other things. This is my light diffuser / reflector. I also have some reflectors around somewhere with different colors, and they all reflect light differently. It's not only material, but also the color and shape that comes into play. When it comes to the sun, it sends out a bunch of electromagnetic spectrum from gamma to radio, and moon absorbs part of it. Then it reflects back polarized light. So please don't expect moonlight to be the same as sunlight. If you do the same test on a moonless night, you get the same result. The shade part is warmer. The process by which a body loses heat by thermal radiation is called radiative cooling, and this process can be influenced. A common example is double glazed windows we have in UK. By using air or gas inside two sheets of glass, it creates a thermal buffer that reduces direct solar radiation, which means less heat gain and heat loss. Similarly, in simple terms, a shade reduces heat gain and thus cooler during the day, but also traps the heat, which means hotter at night compared to ambient temperature. Obviously, from the size, height, even the shape of the shade would affect the final result. It behaves similar to clouds. Hope that clarifies it all. Well, that's all for this video. Thank you so much for watching. If you have enjoyed this content, well, a like and a comment won't go amiss. If you would also subscribe for future contents like this, it would definitely help my small channel grow and would be thoroughly appreciated. Have a safe day. Signing off.
We are one people, and we, like you, we are one tribe.